Welcome everyone. Let's begin our lesson for today by going over our learning goals and success criteria. First, what are we learning? We're learning how to recognize patterns in linear functions and exponential functions, and how to recognize the differences between linear functions and exponential functions. How are we learning it? Through the comparing linear and exponential functions notes and the comparing linear and exponential functions assignment. When could we use this? We could use this to examine sales trends at work to determine how much growth is occurring within the company sales. How do we know we learned it? By getting a score of 4 on the comparing linear and exponential functions assignment. Now let's take a look at our agenda for today. We'll begin by going over our learning goals and success criteria, and while we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the comparing linear and exponential functions notes. Then I'll give you time to complete the comparing linear and exponential functions assignment. After you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is to continue working on the exponential function study guide and any incomplete assignments that you may have. Let's take a look now at the comparing linear and exponential functions notes. We begin our notes with our learning goals and success criteria. Now, first of all, what is a linear function? A linear function occurs when the graph of a relation set forms a straight line. So when we plot the points, if it forms a straight line like this, that means it is a linear function. Now, what does a linear function look like as a table? Well, if we look at the table here, the rule is if all of these in each column, so this column and this column, if the change is all consistent and it's addition, then we say that the set is linear. So for instance, we have 1, 2, 3, 4. So we can see that it is consistent, there is a consistent pattern, and the pattern is that we're adding by 1. So that's addition. So now if we look at this side, we have 2, 4, 6, 8. Again, consistent pattern, addition by 2. So is there a steady change in the number of months? Yes, we're changing by 1 month each time. Is there a steady change in the amount of rainfall? Yes, there is. We're changing by 2 each time. So therefore, we could say, yes, this set is linear. And if we were to graph it, it would look something like this and form a straight line. So that's a linear function based on a table. Now from graphs, again, the rule is they form a straight line. So this is an example of a linear function. This is also an example of a linear function. As is this one. It can go up or down. It can be really steep or really flat. This is another example. Again, really flat and going downward. This one's steep and going downward. So all of these form what we call linear functions. Now, how can we recognize linear functions as an equation? Well, it should be able to form y equals mx plus b. Or it could be f of x equals mx plus b. An example of this would be y equals 1/2 x minus 3. This would be an example of a linear function. Notice the powers for both y and x are 1. Now what is an exponential function? An exponential function is a function that forms a curved line that has a line that it will never cross. For instance, this is an exponential function. It's a curved line, it's a single curve, it starts low and works its way up. It could go this direction also, start high and work down. But it has a line it never crosses. Notice this line gets really flat here at the x-axis. It will never cross the x-axis. So there's a line here that forms that it'll never cross. In this direction, it'll keep going and going and going and get really steep. How can we recognize exponential functions from a table? Well, first of all, the rule is the number of months, my x values, should be changing by a consistent amount, and it should be addition. And my y values should be changing by multiplication. So in this case, we have the months. So this is 1, 2, 3, 4. Well, is there a steady change in the number of months? Yes, there is, and it's changing by 1 month each time. Now here we have 2, 4, 8, 16. There is a steady change, and it is multiplication. We're multiplying by 2 each time. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we're seeing a steady change and it's multiplication. It is doubling or multiplying by 2 each month. So therefore, is this exponential? Yes, it is. And if we were to plot these points, it would look something like this and form this curve. Now, what do exponential functions look like as graphs? They always form a curve, a single curve. So, for instance, this is an exponential function. This, even if I shift it over, it's still considered an exponential function. If I have it go downward, that's an exponential function. And if I have it go below the x-axis, still an exponential function. All of these are examples of exponential functions. Now, exponential functions are of the form y equals a to the x times b. Or it could be f of x equals a to the x times b. Here, an example of this is y equals 3 to the x times 4. Now, if you notice in all of these, y has a power of 1, and x is the power of the base number. So these are exponential functions. So how can we compare these? So the question says, based on the table below, does each table represent a linear function, exponential function, or neither? Well, if we look at this one, we have 1, 2, 3, 4, 5. So this one's consistent and going up by 1. So it could be either linear or exponential at this point. Then we have 3, 6, 12, 24, 48. Well, 3 plus 3 is 6. 6 plus 3 is not 12, so it's not linear. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So that means it's got to be exponential. Now this one, 2, 4, 6, 8, 10. So we do have a consistent pattern. We are adding by 2. So it could be either linear or exponential. Then we have 1, 2, 3, 4, 5. Well, 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5. So they're both consistent, they're both addition, therefore it's got to be linear. Now this one says -2, -1, 0, 1, 2. So again, we're adding by 1 each time, so it could be either linear or exponential at this point. Then we go 8, 4, 0, 4, 8. So here we subtracted 4, then we added 4, added 4. So it's not a consistent pattern, so therefore it's neither linear nor exponential. Now we have our graphs. We're supposed to determine whether it's linear, exponential, or neither. Well, this first one does have a curve, but it curves in both directions, which we know that exponentials only curve in one direction, so therefore this is neither linear nor exponential. Then this one, we have a straight line. Well, we know a straight line forms a linear function, so that one is linear. This one has a single curve, so that one is exponential. Now, looking at the equations, we have y equals 2/3 x minus 4. Well, both of them have a power of 1, and we have both the x and y, so that one we said was linear. It also looks like y equals mx plus b, so we know it's linear. Now this one is y equals 2/3 times -4 to the x power. Well, we should notice that looks like b times a to the x, which is exponential. So this one is an exponential function. This one says y equals 2/3 times the absolute value of x minus 4. Again, it looks similar to this one. We have x to the first power and y to the first power, but the absolute value changes things, so it is neither linear nor exponential. Let's take a look now at the comparing linear and exponential functions assignment. The assignment begins with our learning goals and success criteria. If you scroll down, you can take a look at our questions for today. So the first one says, based on the table, does the table represent a linear function, exponential function, or neither? Well, remember, in order for us to have a linear pattern, we have to have a consistent pattern of addition in both columns. In order for it to be exponential, we have to have addition here and multiplication here. And if it's neither, that means that there's no common pattern, or it's not addition or multiplication. So let's take a look. So we have 1, 3, 5, 7, 9. Well, we can see that there is addition there, right? Because we're adding 2. 1 plus 2 is 3, plus 2 is 5, plus 2 is 7, plus 2 is 9. Then from here, 2, 4. So we added 2. Then we added 4. Then we added 8. Then we added 16. So far, it's not addition. Could it be multiplication? Well, 2 times 2 is 4. Times 2 is 8. Times 2 is 16. times 2 is 32. So that is an exponential function. So that's how we do it with the tables. Let's take a look at the equations. Remember, an equation for a linear function is y equals mx plus b. So this one is, and for an exponential function, it's a to the x times b. Well, if we look, this one doesn't have either y equals mx plus b or a to the x times b, so this is neither. So you'll answer these questions. Then we'll pick out from the graphs. And this should take us to the end. At the end, you'll go ahead and click Next. And this will send you on to your Before You Go. Fill out your Before You Go and then submit your work on Google Classroom.